So here we're going to look at Unit 7, Exponents in Scientific Notation, Lesson 2. And our warm-up question is 100, 1, or 1/100th. Claire says she sees 100. Tyler says that he sees 1. May says she sees 1/100th. With whom do you agree and why? If you look at what May has said, 1/100th would be one of these little tiny squares out of all of them. So if you see that you would agree with May. If you agree with Tyler to see 1, you see one big giant square there, Tyler. And then for Claire, Claire says she sees 100. Well, if you look at all these squares and you counted them all, you would count to 100 if you counted them all. Or a 10 by 10 square, there's 100 little smaller squares inside the one large square that Tyler sees. So depending on your point of view and your reasoning, you could agree with any of them or all of them. This next little bit is not in your red folder, but I feel like this is quality stuff and maybe might be more helpful to get us started. So we're going to take this expression x to the third times x to the second and expand that. So what that means is I'm going to write x to the third as x times x times x. That's x to the third right there, if I broke that all down. And then if I break down x to the second down, that would be x times x. B part says rewrite the expanded form using exponents. Well, I've got 1, 2, 3, 4, 5 x's, so I could write that as x to the fifth. So comparing what we started with to what we ended up with, what operation, add, subtract, multiply, or divide, can be used on the exponents to get part B? From part A to part B, what did we do with those exponents? Okay, and I'm not going to answer that question. We're going to keep doing quite a few of these. Expand the expression using the definition of exponent. So looking at this one right here, we've got w to the fourth times w to the third. And if I expand that, w to the third would be w times w times w. There's w to the third. Times w to the fourth would be written as w times w times w times w. Now rewrite that using exponents. So how many w's do I have here? That would be w to the seventh. So comparing part A to what we got for part B, what operation can be used on the exponents to get part B? Number 3, h to the second times h to the fifth. So expand h to the second to h times h. It's h to the second. H to the fifth would expand to times h, 3, 4, 5. And then it says rewrite that expanded form using exponents. That would be 7th. So what operation did we do? Add, subtract, multiply, or divide to go from h to the second times h to the fifth to make it h to the seventh. P to the fourth times p. So if I write that out, expand it, p to the fourth would be p times p times p times p, then times this last p. So if I rewrite that using exponents, 1, 2, 3, 4, 5. So p to the fifth. From p to the fourth times p to p to the fifth. What operation can be used on the exponents from the original problem to get to part B? N to the third times n to the fifth. If I expand that, n times n times n times, there's n to the third, n to the fifth, 1, 2, 3, 4, 5. And if I write that just using exponents, how many n's do I have? So what operation did I use to go from this to this? Now we're going to get into something that's a little more complicated. Expand the expression using the definition of an exponent. Okay, so we're going to take 3 to the second power and write that as 3 times 3. We're going to take x to the fourth and expand that as x times x times x times x. Y to the second as y times y. So I just took care of that first little expression there. So then the second one in parentheses, I've got a times 3, a times x, and 5 y's. 1, 2, 3, 4, 5. Now I can rewrite that using exponents. So if it helps to color code it, then let's color code it. So I've got how many 3's here? Base 3's. Okay, 3 3's. So that would be 3 to the third. How many x's? 1, 2, 3, 4, 5. So that would be times x to the fifth. Y's, there's 1, 2, 3, 4, 5, 6, 7. So y to the seventh. So comparing from the first to the second part, what operation did we use? Have you guys figured that out? So if you have, what I want you to do, just in your red folder where it says number 1, I want you to write the product rule for exponents in your own words. So take time to do that, and then we'll talk about it when I get to return to you. We are not going to do this part right here, the picture of a power of 10, so just write your product rule in your own words right here. And we're going to skip this part. Now this part, if your OneNote is functioning, I highly recommend you playing with this because this is kind of cool, I thought. If it'll let me do it. So it has some zoom in and zoom out features on it that are kind of fun to play with. So if you zoom in, you get closer in on the bird. You keep clicking, you can get closer in on the fish. You click on it again, and there's an ant. Now you guys can keep zooming in for that if you like. I didn't find anything smaller than an ant. But it just kind of gives you an idea of why exponents are useful. So now we're zooming back out. And if you keep zooming out, this is a very bizarre looking elephant, I think is what that's supposed to be. But then to give you an idea of, even though elephants seem really big, look at that whale. So you guys, I don't know if anything is bigger than the whale on this particular applet, but that gives you an idea of why we can use exponents and why they are useful. So here we go. Complete the table to explore patterns in the exponents when multiplying powers of 10. You may skip a single box in the table, but if you do, be prepared to explain why you skipped that. So on this, because of what I've already done with you, I think you could be able to do this part on your own. So 10, I'm going to use the X. So this is the first part. There's the third part, or second part, excuse me. So then 10 to the 7th. I'm going to go ahead and do that so I don't have to do the formatting again. Alright, so here I got 10 to the 4th. Well, I just wrote that right there, so I'm just going to copy that and put that right there. And then 10 to the 4th again. So this is not 10 to the 7th, but 10 to the 8th. Alright, now this part right here, I'm going to copy this formatting. This is 10 to the 3rd times 10 to the 5th, and that would make 10 to the 8th also. 10 to the 18th times 10 to the 23rd. Are we going to write 18 tens and then 23 tens? Or have we figured out the rule yet? Okay. So this is again a place for you to use the patterns you found in the table to write an equivalent expression with a single exponent. Use your rule to write, what does this tell you about the value of 10 to the 0? The state of Georgia has roughly 10 to the 7th human residents. Each human has roughly 10 to the 13th bacteria cells in his or her digestive tract. How many bacteria cells are there in the digestive tracts of all the humans in Georgia? So it would be 10 to the 7th times 10 to the 13th. And then tell me what you think that would be equal to. So here are some things that we're going to talk about when I get to return. How could you write 10 to the 15th times 10 to the 5th using a single exponent without expanding all the factors? In general, what is a rule for multiplying two powers of 10 together into a single power of 10? And here we've got the summary, so if you haven't caught on to it yet, the summary will help you out. The substitute is going to give you the practice, so you guys can get some practice on this and some spiral review. And we will catch up on this when I get back. Thanks for listening.